The next differentiation technique that we're going to learn about is the quotient rule. So suppose we have a function that is a quotient of two other functions. How do we take the derivative of that? Well, it turns out that the derivative of a quotient is not the quotient of the derivatives. To see why, let's take an example. Let's look at q of x equal to the quotient of x to the fifth over x squared. Now we could simplify this function and write it as q of x equal to x cubed. And we have to assume here that x is not equal to 0. Now if we use the product rule to find this derivative, we get that q prime of x is equal to, bringing the exponent out in front, 3x, and then subtracting 1 from the exponent, we get 3x squared. So 3x squared is our derivative of this function. Now, let's off to the side here see what happens when we take the derivative of the numerator and the derivative of the denominator. If we take the derivative of the numerator using the power rule, we have 5x to the fourth. Now if I take the derivative of the denominator, I get 2x. And then this simplifies to 5 halves x cubed. Now notice how 5 halves x cubed is not the correct answer for the derivative. The correct answer for the derivative is 3x squared. So this gives you an example of how we can't simply take the derivative of the numerator and divide that by the derivative of the denominator to get the derivative of a quotient. So in order to find the derivative of a quotient, we need to use the quotient rule. So suppose we have a function q of x given by a numerator function n of x divided by a denominator function d of x. The derivative for that then is q prime of x, which is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, and then that is all divided by the denominator squared. So this is the quotient rule that we will use to find the derivative of a quotient. So let's consider the function f of x equal to 2x to the fifth plus x squared all divided by x. We're going to find this derivative using the quotient rule. And what I'm going to do here is label my numerator function with an n and my denominator function with a d. And then off to the side here I'm going to write down what the quotient rule is. We take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Alright, so f prime of x then, the derivative of this function. First is the denominator, which is x. Next, times the derivative of the numerator. So taking the derivative of the numerator, 2x to the fifth, bringing the 5 out in front is going to give us a 10x to the fourth, plus the derivative of the next term there using the power rule is 2x. So that's the derivative of the numerator minus, now we're writing down the numerator, 2x to the fifth plus x squared times d prime. So the derivative of the denominator, the derivative of x is 1, all divided by the denominator squared. So in this case, x squared. So now we can simplify this. Distributing the x, we have 10x to the fifth plus 2x squared minus 2x to the fifth minus x squared, all divided by x squared. Combining like terms, 10x to the fifth minus 2x to the fifth leaves us with 8x to the fifth. And then a 2x squared minus x squared leaves us with a 1x squared, all divided by x squared. Next, we can factor out an x squared from the numerator. Factoring out an x squared, we're left with an 8x cubed plus 1, all divided by x squared. So now our x squareds are going to cancel, and we're left with an 8x cubed plus 1. Keeping in mind we have that restriction on the x. X cannot be 0. So our derivative then, f prime of x, we found to be 8x cubed plus 1 with x not equal to 0, since 0 is not in the domain of the function. Next, in part B, we want to find the derivative by dividing the expression before differentiating. And then we're going to compare our results to what we got in part A. So I can simplify this function by factoring out an x in the numerator. So if I factor out an x, I have 2x to the 4th plus x. And the reason I factored out an x is so that it'll cancel with the x in the denominator. So now our function looks like 2x to the 4th plus x. So now that I no longer have a quotient, I can find the derivative by using the power rule and the sum difference rule. So f prime of x then looks like, using the power rule, bringing the 4 out in front, we have an 8x cubed plus 1 as our derivative. And again, we also have that, keep in mind we have that restriction that x cannot be 0, since 0 is not in the domain of the original function. So now if we compare our answer to what we got in part A, notice we do get the same thing. We got that our derivative f prime of x was 8x cubed plus 1. Now in this example, it was just as easy to simplify our original function and eliminate the quotient before taking the derivative, as we did in part B. However, sometimes if we have a quotient for a function, it is not that easy to simplify it and take the derivative. So when we can't simplify our quotient, we use the quotient rule to find the derivative.